Welcome back to yet another experiment about Rutherford. So Rutherford was one of the great scientists in chemistry and physics. So let's begin with his works, Rutherford's experiments, Godfoil experiment and the nuclear model of the atom. So before J.J. Thomson proposed the Bram-Paddy model, then Rutherford came and challenged J.J. Thomson. Atoms thought to be a sphere of positive charge with electrons embedded. So Rutherford wanted to test this model, and therefore he developed the idea of carrying out the Godfoil experiment in the year 1909. So he was a scientist, so he instructed two physicians, Geiger and Marsden, who conducted the experiment as he was observing. So what did he do? He got the alpha particles, struck them with pure thin sheet of gold foil. It was very thin, it was just like 1,000 atoms in thickness. And he measured the intensity with which the particles passed through the thin foil. So now this is set up. Source of alpha particles, he had a source. Then he also had a very thin gold foil, about 1,000 atoms thick, we talked about it. Then around the gold foil, he surrounded it with a fluorescent screen. And that fluorescent screen would glow in case it was struck by an alpha particle. And then these alpha particles were observed under a microscope. Observations, what did he observe? Most alpha particles passed straight through the atom. Some were deflected at small angles, implying that there would be some electrons inside the electron. Then a very few bounced back, large angle deflection. So those very few which bounced back, they were believed to have collided with the positively charged center with a heavy mass, which was believed to be the nucleus. So in conclusion, therefore, Rutherford concluded that the atom's space is mostly empty. Why? Because we see most alpha particles are passing through direct without any diffraction. Then he also concluded that positive charge and mass are concentrated in a small dense nucleus, the one which was in the middle and deflected light back in a straight line. Then he also concluded that electrons orbit around the nucleus. Why? Because we see some alpha particles being reflected at some angles. So they were believed to be deflected by the electrons in the orbit moving around. So Rutherford disapproved Bram-Paddy model by J.J. Thomson, introduced nuclear model of the atom. So in short, he was the founder or the father of the nuclear model of an atom, on which Bohr's model and modern quantum physics is based. But his experiment also had limitations. One, it could not explain why electrons do not spiral into the nucleus. It also didn't describe electron energy levels, which were later explained by Bohr in his experiment. So what he changed was very much, and changed the way scientists view the atom, opened the door to nucleus, still considered one of the most important experiments in physics. Thank you so much. You can subscribe to our channel so that next time we upload a video, you keep in touch. We hope to meet next time. Be safe.